Hi, 10:30. We are now on the last part of part 4 of our Unit 4 review. So it says, which of the following pairs of triangles appear similar? To be similar, remember that we have the same shape, different size. So same shape, different size is what's really important. If you look at all these that we're seeing, if I can get my little mouse over here. All right, so these are not the same shape, are they? Between the two. This one is a right triangle. It looks more like a right triangle than this one, and they're not quite the same. These two are not the same. This one looks almost equilateral. This one not so much. These two look pretty much the same, don't they? This one's just a smaller version of this one, so I'm going to say choice C. And then D, they look different too, this obtuse angle. This is a right, more obtuse and right. So I'm going to go with choice C. Remember, similar triangle, same shape, different size. All right, and that was 33. We'll move on to 34. 34 says, identify all the symmetries in the following figure. I'm going to screen capture this so we can look at a couple of things. If you're looking for symmetries, then you have two different types. You have a rotation and a reflectional symmetry. So if I'm first of all going to look at reflectional. All right, so if I reflect it over those two lines, so if I reflect it down, and for this horizontal reflection, then as I reflect it, it's going to look exactly the same, and that's the rule. It needs to look exactly the same after the reflection has happened, and indeed it will. So it remains unchanged, and therefore it has a horizontal. That's one symmetry. The other one is that way, so vertically. So I'm going to say that's going to be two reflectional, reflected, two lines that it can be reflected across. And then let's look at rotational. So those are going to be the same. Rotational, so gosh, I probably ought to be able to change my color, right? To pink. So if I move this down to right there, that's 45 degrees. And that, is it going to look the same? No, but it's going to make it a little, it's going to make it vertical and not horizontal, right? So it can only be rotated to here, and then if I rotate it to there, 180 degrees, then it will remain unchanged. So it's going to be one 180 degree rotation and then two lines for which it can be reflected. So let's see, where are those answers? Two lines from which it can be reflected, and it can only be reflected or rotated over 180 degrees. So that one is it. All right, next up is 36. Well, these are the easy ones. I love this section. It's in the geometry chapters, but tilings. So tilings, which I call tessellations, are found by rotating or reflecting or using some type of translation any object to where no gaps occur and no overlapping pieces occur. So if you're reflecting or rotating or translating this figure right here, this triangle, here it doesn't look like they've done a very good job because you have gaps. And here we have gaps. So A and C are out. When you're looking at these two, these are looking pretty good. Oh, and it can only be translation, so it has to be slid. So it looks like it's going to be B because you're sliding it, and what you're creating is a gap that can be fit right inside that. So a translation is meaning a slide, and that would be a great picture of a tiling done with translations only for B. All right, and then our last question is 37 right here. It says the sides of a rectangle are given. So you have a side that's 3 and a side that's 4.8. Is a rectangle a golden rectangle? And in order to do that, figure that out, then the ratio of the long to the short side must equal something near 1.6. So if we take 4.8 and divide by 3, if my calculator's on, that always helps. 4.8 divided by 3, and that's 1.6. So indeed it is. So the answer is yes. Covered up. All right, those are the last of the review questions that I was going to do. And I hope you guys have a great time taking the test, and you go through these review questions and go in totally prepared. Good luck.